Okay, so let's get started. We're going to be taking a look at understanding and working with our cylinder trim programming found within our Motec M1 systems. Now, cylinder trim programming is going to be important because we want all of the cylinders to have equal combustion. And in order to achieve that, we want to make sure that if there's knock or pre-ignition happening in a cylinder, we want to detune that cylinder so that that cylinder is not going to be weighing on the knock control and constantly, let's say, retarding the timing in there. And then in the fueling side of things, we want to make sure all of the cylinders are going to have adequate fueling. So if we have an imbalance in our intake manifold design, for example, pretty common, we'll find that all the cylinders don't get equal airflow. In that situation, we might want to go in and pull some fuel out of certain cylinders, and other cylinders might need a little bit more fueling, depending if we get more or less air through the intake manifold distribution. So there's reasons why we like to dial in our cylinder trims, but it's going to be something that we definitely have to do after we've already calibrated and tuned our fuel and airflow model and our spark timing. We have the knock control set up. With the knock control, we can see the individual cylinder's behavior. If we're finding that we're getting a certain cylinder that's knocking, we can utilize a spark timing compensation table in that cylinder alone and detune the cylinder so the knock control is not constantly going in and attacking that knock event that would happen on a particular cylinder. So let's jump in here and take a look at where we can find our individual cylinder trim tables. We'll talk about what they represent, and then we're going to talk about how to set up the tables so they have proper axes, and then just discuss what we do in general in terms of attacking and calibrating the tables. So first things first, I'm going to move from my field tuning page here and jump all the way across here over into the cylinder trim area. This page is set up for a 4-cylinder engine. If you have a 6 or an 8-cylinder engine, you can add on more tables in here. You can also add on some more parameters based on those cylinders, but the idea with a 4-cylinder engine, that's what I'm working with here, a Honda K24 engine, will be the same. So in terms of how the tables work and the editing functionality, it's going to be the same whether it's a 4, 6, 8, 10-cylinder engine. It doesn't really matter. All right, let's jump in here and take a look and talk about what we have to program. What we're going to find first thing is that we have all of our fuel cylinder trim tables on our left side. On the right side here, we're going to find our cylinder spark tables. In the fuel trim table here, this is a percentage of adjustment to whatever the calculated pulse width is coming out of our main air and fuel modeling. So we know that we have a certain amount of airflow we represent through a bunch of calculations, as well as the VE table values. It's going to allow us to determine engine load or air mass. We divide that by our target air fuel that's found knowing the fuel stowage and the desired lambda. So we multiply fuel stowage by target lambda, desired lambda. That gives us our target air fuel. If we know that, then we can calculate fuel mass. We can convert a fuel mass into an injector pulse width through knowing our injector flow and injector data. Once we obtain the actual injector pulse width that we want to pulse all the injectors at evenly, then the cylinder trims will be a percentage modifier to that actual pulse width. So if we have a value in here of plus 10 in one cylinder and minus 10 in another cylinder, it would alter the pulse width by 10% in one and then taking away 10% in another. So for example, if I have 2 milliseconds of pulse width calculated, and I have a value here of 10%, that would mean my adjusted pulse width would be 10% higher in our fueling delivery. Likewise, if I have negative 10 here, it would take away 10% from the calculated pulse width of 2 milliseconds. So we can either add or subtract fueling based on whatever that calculated pulse width is going to be. Taking a look here at our cylinder trims for spark, this is going to be degrees before top dead center reference. This will alter whatever the spark timing is coming from our main spark timing table and any of our spark timing compensators. So we know we have ignition timing, that's the actual timing delivered to the engine. Then we have our ignition timing main, that's what's commanded here from the table. Those two don't necessarily match up at all times. We might have a modifier table in play, such as our engine coolant temp spark or intake air temp compensation or engine load compensation. So there's things that can alter the spark timing, which will be reported here from our ignition timing. That's the actual timing delivered to the engine. Now in this situation with a cylinder trim, this is what it actually gets altered. So bottom line, it takes away the timing that we report here from a particular cylinder. So for example, on my 4-cylinder engine, I'm direct fire. I have 4 coils. Each coil is fired once per cycle. And then I've also told the Motec my firing order, and it knows on a particular coil as it's sending the signal to trigger the coil what cylinder I'm on. So therefore, it can detune just the cylinder. I can either advance or retard the timing from the main spark timing table value here, as well as the, well, I guess the calculated value, I should say, not the main spark timing table. So what we have coming out through all of the compensations, it alters that to just that cylinder. So we can advance or retard the timing. So let's jump back in here and take a look at a couple additional things. What we're gonna find here is that the tables right now are all set to 0. So 0 fuel trim or 0 spark timing compensation. So that means that everything here has been zeroed out. If you don't want to use any of the individual cylinder trims, just simply set all the tables to 0.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.